Hello and welcome to another exciting chemistry session. This is your host, Mr. Monson. So I'm beginning to run a series on redox reactions. So what you're looking at now are the learning objectives under this particular topic. So for today, we just like to talk about how we can describe a redox reaction, knowing that a redox is just an acronym of oxidation and reduction reactions. So basically for today, we'll just focus on defining or describing what is a redox reaction, what is oxidation, and what is a reduction. So allow me to scroll down quickly so that we can dive right into our description. So oxidation and reduction is what makes what we call the redox. So a redox is just a short form of writing oxidation and reduction reactions. So these reactions can be defined in four ways. A redox reaction can be defined in four ways. We can define a redox reaction, first of all, in terms of oxygen. It can be defined in terms of hydrogen. It can be defined in terms of electrons, and it can also be defined in terms of the oxidation number or the oxidation state. So just to summarize, oxidation in terms of oxygen, we say it is a gain or an addition. I will describe more by giving examples. So oxidation is basically the addition of oxygen or the gaining of oxygen by a chemical substance. When a chemical substance gains oxygen or oxygen is added to a chemical substance, that reaction is referred to as an oxidation reaction. Then the opposite is the reduction reaction. If a chemical substance loses oxygen, that is deemed to be a reduction reaction. Then they can also be defined in terms of hydrogen and in terms of electrons. But in terms of hydrogen, when a chemical substance loses hydrogen, we say that is an oxidation reaction. Then when a chemical substance gains hydrogen or hydrogen is added to a chemical substance, that is deemed as a reduction reaction. In terms of electrons, when a chemical substance loses an electron, that is oxidation. When a chemical substance gains an electron, that is reduction. In terms of oxidation number or oxidation state, when the oxidation state of a certain chemical element increases, that is oxidation reaction. When that element or a chemical compound loses its oxidation number, that is deemed as reduction reaction. Now let's go into the details. Let's look at this table. It shows, describes how we can define oxidation and reduction reactions in terms of oxygen. So to my left, we have the oxidation reaction, and to the right, we have a reduction reaction. These are basically examples. So we are saying oxidation is, let me just underline to make it more clear. So oxidation is again, or the addition of oxygen to a chemical substance. So we have an example of zinc. We have zinc plus oxygen. So this is a combustion reaction. This is a combustion reaction. So oxygen has been added to zinc. So let's take it that this is zinc 2, not zinc 1. As you can see in the formula, we're going to get Z capital Z, small n, then capital O to show that this is zinc 2. So oxygen is being added to zinc, and this is what we call oxidation. So in the statement there, we say zinc 2 gains oxygen to become zinc 2 oxide. So zinc has been oxidized. That is basically the terminology that we normally use. Zinc has been oxidized. So when you talk about oxidation of zinc, you're just getting the oxygen, then you're adding it to zinc, then you form zinc oxide. So that reaction is called an oxidation reaction. The second reaction, you have carbon plus oxygen. This is a combustion reaction. Oxygen is being added to carbon and you're producing carbon dioxide. So carbon gains oxygen to become carbon dioxide. So the addition, just the attachment of oxygen to an element of carbon, that is what we call oxidation. Let's look at the opposite. The opposite is reduction. What is reduction in terms of oxygen? So here we're talking about in terms of oxygen. Oxygen. We're just focusing specifically on oxygen. So reduction is the loss of oxygen. Oxygen is being removed from a chemical compound. Let's look at this example. We have sodium oxide. This is a displacement reaction. A more reactive metal, which happens to be potassium, is replacing sodium. Is this a possible reaction? Which one is more reactive between the sodium and potassium? And you go to the reactivity series of metals. So let's take it that potassium is reactive. So potassium is substituting sodium. So sodium is being replaced by potassium, and then you have potassium oxide and sodium. So if our focus is basically on oxidation, if you look at sodium oxide, so sodium oxide is losing the oxygen. The oxygen is being removed from sodium oxide. So we say sodium oxide as a compound has lost the oxygen to become sodium. So it's becoming sodium when you check the other side. It's becoming sodium. It doesn't have the oxygen. It no longer possesses the oxygen. So that is what we call reduction. Another example is carbon reacting with carbon dioxide. And this is a reaction that we see happening in the extraction of iron in the blast furnace. So carbon is losing its oxygen. Carbon dioxide, sorry, is losing its oxygen to become uh, carbon monoxide. To become carbon monoxide. So it's not really losing the entire oxygen, but it's losing a bit of it. It can also be deemed as oxidation because it has lost part of its oxygen. So that is how we define oxidation and reduction in terms of oxygen. Let's run quickly and look at oxidation reduction in terms of hydrogen in the next table. So the next table shows the oxidation reduction in terms of hydrogen. So we said in terms of hydrogen, oxidation is a loss of hydrogen. Loss of hydrogen. So hydrogen is being lost from a chemical compound. Let's look at this example. We have ammonia. This is ammonia gas, NH3. Hydrogen is attached to nitrogen. Then when we pay a closer look, here we just have the nitrogen independently without the, the, the hydrogen. So that basically shows that the hydrogen has detached from the nitrogen. So that detachment, that losing, that removal of hydrogen is what we call oxidation. So ammonia becomes nitrogen. So ammonia loses hydrogen to become nitrogen molecule. Nitrogen has been oxidized because it has lost hydrogen. In the second example, we have the decomposition of nitric acid. Nitric acid decomposes to produce nitrogen dioxide and water. So when we check here again, we'll notice that this compound is no longer having the hydrogen. So that is a loss. A loss of hydrogen is what we call oxidation. Let's look at reduction. Reduction on the other side is the gain of hydrogen. Hydrogen is being added to a chemical substance. So just the reverse of the, the reaction. The production of ammonia, this is called the Haber process. When we are producing ammonia, on the reactant side we mix nitrogen and hydrogen and then we produce ammonia. So they combine in the ratio of 1 to 3. So on the reactant side, nitrogen is a standalone, but on the product side, nitrogen is attached to hydrogen. So that addition, that gaining of hydrogen is what we are referring to as reduction reaction. The reverse of the other reaction, combining nitrogen dioxide and water to produce nitric acid. This is known as the Oswald reaction, the Oswald process, the process that we use to prepare nitric acid. So at a certain point, nitrogen dioxide is added to water. Sometimes dinitrogen tetraoxide is added to water, and then we produce nitrous and all those compounds. So our interest here is just the formation of what is known as oxidation, what is known as reduction. So that is in terms of hydrogen, it is a loss. I hope that is very clear. Let's proceed and look at in terms of electrons, oxidation, reduction in terms of electrons. So in this table, we demonstrate how electrons are being transferred and how electrons are being gained. There's a loss and then there's a gain. So we are saying oxidation is the loss. Normally we use these acronyms known as oil, 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 oil. So oil defines oxidation and reduction. So oxidation is the loss, that is the oil. Then the reduction is the gain. So here we're talking about oxidation, reduction in terms of electrons. So oxidation, we lose electrons. Then reduction, we gain an electron. Now, taking you back to the metals, we say all metals lose electrons, then all non-metals gain electrons. How do we present this? So, taking you back to the formation of an ion, how do we form an ion? So, if I have sodium, metal, and then minus, taking the minus, meaning losing. Don't cut me wrong, I'm just trying to demonstrate something. So sodium minus, its valence number is 1, so we say it's losing 1 electron to produce sodium ion, to produce sodium ion. So that is a loss, that is the oxidation reaction. Sodium has lost its electron. But in chemistry, we do not use a minus. We do not use a minus in the equations. In an equation, we always use a plus. Therefore, this negative is forced to go on the other side. Therefore, this is presented as sodium equals or will produce RO, sodium ion plus an electron. So you basically see such a representation of an oxidation reaction. So here we have copper producing copper 2 ion plus 2 electrons. So it means that copper has lost 2 electrons to become copper ion. Remember, metals lose and non-metals gain. So that is just a demonstration. Some people wonder why we have a positive on the other side. So it's a minus, but we do not use a minus in chemical equations. So you take it on the other side so that it becomes a positive, and then it will give us the right interpretation of the definition, which is the loss. Again, when we go back to the charges, an atom is neutral, therefore its charge is 0, and the charges on the reactant side should be equal to the charges on the product side. So to make sure that that is balanced, that is why we also transfer this negative to the other side, so that a positive ion means positive 1. An electron by nature is a negative, so if we have 1, it means negative 1. So negative 1, positive 1. Eventually on the product side we also have a 0, so it means that the reaction is balanced. The second reaction there, it's one and the same thing. Sodium, ion 2 loses an electron to become ion 3. So you put the electron on the other side. The charges should always balance. So here you have a positive 2, there you have a positive 3, then an electron which is a negative 1, then you get a charge over a positive 2, which is also balancing on the reactant side, which should balance to the reactant side. So that is, normally people get confused, but that is how we present the equation. So we don't use negatives in the equation. Then on the other side, we're saying it is again of electrons. Oxidation is the gain. So if I have magnesium ion and then it gains to electrons, sorry, it gains to electrons. So it's going to become magnesium atom. So the gaining of two electrons, is what we are calling as reduction. If you go back to the atomic structure, looking at the electronic configurations, this is 2,8. So this guy will gain two electrons, so that it can take us back to the electronic configuration of 2,8, 2. So basically that is what we try to balance. But the key thing to take note of here is oxidation in terms of electrons is a loss. Reduction in terms of electrons is a gain. So a nonmetal can gain, a nonmetal can lose. That is just chemistry. It's just the loss, the transfer, the gain that basically defines what we are calling as oxidation and reduction. I hope that is clear. So if we look at fluorine, this is fluoride. So fluoride uh, is losing away the electron to become fluorine. So it is stable as a fluoride. When it loses, it becomes unstable, becomes an atom which is a fluorine. So basically it's just the loss and the gain. I hope this is clear, and it brings clarity to to the confusion that we normally encounter as we define oxidation and reduction in terms of electrons. So it's just the gain and the loss. Understand which one is gaining, which one is losing. Let's look at the last part, which is the definition of a redox in terms of the oxidation number. So oxidation number is basically, we get to learn more about the oxidation number as we determine the oxidation number. There are rules. There are rules that we follow for us to determine what we call the oxidation state or the oxidation number. We'll get to that in the next series. So how do we define oxidation reduction in terms of oxidation state or the oxidation number? So oxidation is again for the increase in the oxidation number. When the oxidation number increases of a chemical substance, then you're saying that is oxidation. When the oxidation number decreases, then that is what we are calling as reduction. So quickly, we have an example of copper. So according to the rules, any independent element that is not combined with another, its native oxidation number is 0. Any element that doesn't have a combination, which is not bonded to any chemical substance, has the oxidation number of 0. So here copper is not bonding to anything, therefore its oxidation number is 0. Then any charged, which can either be an anion or a cation, its respective charge is its oxidation number. So its respective charge, for example, we have X positive. So whatever is there, let me say N positive. So this is what we call as its oxidation number. If we have B M minus, so this is what we'll call as its oxidation number. Therefore, the oxidation number for any neutral element is 0. Then for a charged, which is a cation or anion, so here we're dealing with a cation, its oxidation number is 2. So we say oxidation number for copper is 0. Oxidation number for copper ion is, so I'm sure we are able to see that this is an increase. It's moving from 0 to positive 2. So that increase is oxidation number. Here we look at ion 2. So ion 2, its oxidation number is 2 positive. Then ion 3, its oxidation number is positive 3. I'm sure we are able to see that there is an increase. So an increase in the oxidation number is what we call oxidation reaction. Here we have a negative 1, which is going to 0. So a fluorine is an independent element. It doesn't have any charge. According to the rules, it's 0. So we are moving from negative 1 to positive 0. So that is what we call oxidation reaction. Then the opposite is a reduction. Reduction is when we have a decrease in the oxidation number. The oxidation number is decreasing. So if I have a positive 2 here, and then I have a neutral magnesium, which is a 0, I'm sure we're able to see that this is decreasing from a positive 2 to a negative, to a 0. We have ion 3, which is reducing to ion 1. So this is positive 3, this is positive 1, I'm sure we're able to see that there is a reduction in the oxidation number. We have a 0 which is going to a negative 1, so this is also a decrease in the oxidation number. So that is how we basically describe oxidation and reduction in terms of oxygen, hydrogen, um, electrons, and the oxidation state or the oxidation number. This has been your host, Mr. Monta. Until we meet next time, bye bye.